Now, finally, I'd like to introduce you to the moderator of the evening. I think you can find his bio on the event flyers that you found on your seats. He's a partner of Acro Capital. He's also a father of 3. He enjoys playing Angry Birds on iPhone. He's also an avid snowboarder, which I'm very envious of. So please join me in welcoming Ezra to the stage.
Welcome, everyone. It was 10 or 11 years ago when I last moderated a VLab panel, so I'm guessing enough folks have retired from VLab that I've now invited back. I was there. You were there? Yeah. That's good. I think it was on real estate software or something like that. It was pre-internet, so back in the day. The internet was there. It was there. Well, you know, early on. It was really small. Something like 10 people. Anyway, thank you for having me, and I'm excited to moderate this panel, and it is fun to be here, you know, at sort of the epicenter of the future. And I think these are great venues to really learn about what's happening next. And I think if you're going to find a topic that is on the very forefront of innovation, this has to be one of them on the very short list. And I think we're going to see so many changes coming from the people that we're going to hear from on the panel, from people like our speaker, that are going to bring just a tremendous amount of innovation to you know, both us in sort of the consuming world as well as us in the venture world, us in the academic world, people who are trying to essentially take advantage of new tech. And I was thinking a few things about vision computing. You know, I remember I used to be on a committee. I see Always On is one of the sponsors. I used to be on a committee with Always On where we got to meet companies and pick them for these lists, top 100 this and top 100 that. And about 5 years ago, we had a security software company come in. I won't mention who they were, but I don't think it's confidential what they told us. But he said, you know, we have new technology for tracking who comes in and out of banks and other secure sites. And it's video technology and so on and so forth. And I said, well, isn't that a tremendous amount of video you have to store? Just if you think of filming thousands of bake branches and think of filming all the things that have to go into tracking all this information and data, and how do you index it, and how do you track it, and how do you accomplish anything meaningful from just collecting all of this this footage? And he said, well, the interesting part is we don't actually keep very much footage. In fact, we keep very little. All we look for is the faces and a few other data points, and we're able to essentially aggregate very quickly the information we want. And then we can do all kinds of stuff because now we've limited down the information we collect. We can do very specific things with that data. And it really sort of opened my eyes. It was sort of the first time I thought about things you can do visually that were completely revolutionary to the way things might have been done in the old days, where you were maybe going through reams of video or whatever it might have been to find an answer to something. So I can only imagine what's going to happen in the future and some of the innovations that are happening from our panelists and speakers. I also think, you know, it's going to be exciting when we no longer need remote controls and we no longer need all kinds of instruments that today we think of as sort of things that will be around forever. But eventually, my guess will be we'll just point at things or smile when we like something or frown when we don't, and we'll have all kinds of reactions from computers that will be things we maybe haven't even thought of yet. So with that, and with my great deal of excitement for this topic, and I'm thrilled to have people on the panel from the venture community, from the entrepreneurial community, from the academic community. We're going to have a whole wide range of insights into this topic tonight. But with that, I want to introduce our speaker. So I actually got selected to be on this panel from a show. I'm on an online show on my wife's company, Vader TV, and we had a show a few years ago actually on Vudel, where it was the two of us and Marissa Mayer from Google who was on the show talking about this company. And I think when they Googled you, they stumbled on my video, and they're like, hey, maybe this guy knows something. So my 10-year reunion with VLab. So with Vudel, I want to introduce Laurent Gill. He's the CEO. A really interesting background, everything from investment banking to entrepreneurship, both in Europe. He started and established a boutique investment bank in Brazil, where he completed the largest transaction in the telecom sector in Latin America, which is near and dear to my heart as an investment banker. He was also the CFO of TAHO, a wireless internet service provider. He developed broadband wireless internet network services in Latin America, and then he came back to the U.S. to start Butyl amongst several other projects along the way. So someone who has a technology background, a finance background, and an appetite for a great deal of risk, jumping into a whole new category. So with that, I'd like to introduce Laurent Gill. Laurent, CEO of Butyl, thank you for presenting.
Let's put this presentation. Here we go. Guys, it's a real pleasure to present here. I am delighted to meet such a talented room, and I had a chance to speak to some of you and some of my colleagues as well. Some people that I've been following for a long time as a competitor or as players in the same industry. Some venture capitalists that we used to pitch with no success, right? It goes. Well, I know you're not there anymore. That's good. It's better now. Anyhow, it's a great pleasure because it's a rare opportunity for us to show you the dreams, the dream that 60 of us at Butyl had 3 years ago. By the way, in this room, I have 4 of my most talented members. I have Jason, who runs product. Marisol is doing marketing. Ignacio is a crazy, creative product guy. Denise has nightmare running the development team. Sorry, we help the nightmare. So the reason why it's a real pleasure here is because we have very few occasions to show you the result of our dreams. And this dream is shared by 60 members at Butyl. We have 60 team members. 80% of these are engineers all over the world. We have extremely talented scientists. One of them used to make nuclear reactors in satellites and engines for missiles. And he's the head of our mobile team. So we have incredible professor of university who been working on computer vision for the last 30 years. The good thing for us is you cannot find any of his publication because it's all in Russian. So that's cool. And we have an amazing team in Europe. We have an amazing team in Latin America. We have an amazing team here. And it's a dedication to my team and my company, where I can share with you the dream we had 3 years ago. Our dream was the following. Our dream was, can we use computer vision to solve some problem linked to the consumer? And I'm going to first start this presentation with a very simple definition of computer vision. So this has 6 lines. It's already too much for me to read. This is what matters. Computer vision is ability for the computer to see things and solve tasks. That's what computer vision is. It's the ability to give the machine, it's the ability for the machine to be able to understand its environment from a vision perspective. And according to what the machine understands, the machine can take actions. 3 years ago, this is a dream. I mean, this is impossible to do. It's extremely hard to do from a technological standpoint. Right now, it's reality. And this is what I'm going to show you. I'm going to show you some examples of application of computer vision at Viewdol. We are today able to do real-time computer vision on mobile devices. That's the excitement that we have. This is an example of it. It's a video of a mobile device that is pointed to a person. Now the mobile device is recognizing who that person is. That person is Marisol. She's here. What this video is the ability for a mobile machine. It's an Android, I think it's a Nexus S. Oh, it's a 1 gigahertz ARM processor. It's the ability for a mobile device to identify in real time an object. In this case, the object is a person. But it's not only to say there is a person in front of the camera, it is to say, who is that person? Well, that's Marisol. That's what I said when I was looking at the definition of computer vision, is the ability for the device to understand its environment. In that case, it's the ability for the device to see that in front of the device there is a person, and that person is my friend. And from the moment you know that the person is your friend coming from computer vision, then the device can do funny things. The immediate funny things is like this one. While I'm taking a picture of my friend, and I'm able, since I know it's my friend, I'm able to pull some data from the internet and augment the reality of who my friend is. Or in this case, what is my friend thinking? She cannot believe that her car just broke, is what she's thinking. So the type of, or immediate type of applications that you can use, that we are developing at Viewdol, are a set of techniques and technology that make the machine understand who is in front of it. We started by face, we started by people. We are a small company, we had to start by somewhere, by something. Finding people in pictures and videos on a mobile device in real time makes applications such as photo sharing, video sharing, gaming very, very exciting. This is another type of application you can do. This is a wide angle camera looking at a group of people. The same type of idea. You are identifying who these persons are, and you are pulling out some data out of the internet. Imagine what you can do with this kind of techniques. It's not only you can take the Facebook update, the Twitter update, you can find out when was the last email, you can find out who are his friends, what is he doing, where was the last time I met him. These are the things you can do with computer vision on mobile device. This is not a dream anymore. This is a reality. We have these things in our pipeline. For me and for my team, when we started to realize the things we can do with computer vision, the philosophy of thinking that the machine can understand its environment and solve problems, in this case, it's a very simple one. Take a picture and get some information of who that person is. We think this is extremely disruptive in terms of human-machine interface. If I point my phone to someone, my phone may take the picture automatically just because it's my friend. And I want to share this picture automatically, immediately, because it's my friend, on Facebook. And when it hits Facebook, because it's my friend, then he gets notification immediately. It goes inside the social graph in a few milliseconds. Disruptive means opportunity. And the type of opportunity we are thinking at Viewdol is the following. Our goal, of course, is we want to spread the use of computer vision, especially our APIs, and applications to as many people as we can, or as many people as possible. The type of applications we are working on, and we're actually selling these to some of our partners, are APIs that are all linked to either sharing the moment, which is taking a picture of someone, being able to identify that person, and spread this information along the social graph, or gaming. We are extremely excited by gaming for the fact that with computer vision on the phone in real time, you can start to create games that are linked to reality. They are not linked to location, they are linked to reality. Reality means they are linked to what you are doing, or exactly what the phone is watching. So the typical use case of game based on reality is you point the phone to someone and you ask, are you my friend or are you my enemy? Well, the phone will tell you that. The game starts from there. So business opportunities of computer vision on mobile device are things that are real. It's either an extremely strong social context linked to your personal use of your phone, or it's a gaming area. And we do have partners and clients that are active in both of these buckets. The analogy we like to say is Facebook gives you an identity, an online identity. What computer vision of Udall gives you an identity in the real world. That's what is exciting. We can't say too much of what our products are. They are not, you cannot see them yet in the marketplace, but you will see some announcement we will do in the next few months in terms of using our underlying technology in mobile devices or using our technology inside gaming or inside social type of applications. Opportunity is also challenges. We had a lot of difficulties to do this. I mean, we didn't do this right the first time, and Goza can testify from that. The difficulty with computer vision is that you have to really understand what use case you solve according to the state of your technology. And I think it would be interesting to see video surf because you guys probably had the same type of questions. The idea is computer vision works extremely well in some cases and breaks very easily in others. We have solved the first one, which is computer vision for social apps. Social applications, computer vision means you have to find your 20 friends or your classmate. Other type of computer vision that we are not touching is the security issues. Finding a terrorist among 100,000 or among millions of people at the airport. It is something that we could do with our technology. It is not the use case that we want to solve. So this is the challenge when you use computer vision, is in many cases you wonder, that should work, it doesn't work, the use case is wrong. It took us a lot of time to find this and be excited by realizing that you can use this in a social context. And it's not only this, it's you can use it in a social context in real time. A lot of people always ask me about privacy, and I wanted to say a few words on this. In the case of a social context using computer vision, the privacy we follow is always the same privacy as Facebook. That means that if you share your pictures with your friends, then I'm able, as your friend, to go inside your pictures, apply my machine learning mechanism to get the knowledge of recognizing you just because you shared your pictures with me. So for Udall, the privacy is, I don't want to say it's a non-problem, but it's an easy problem to solve, is, well, as long as you give me, or as long as you give your machine the ability to look at your pictures, you also give the machine the ability to look at the pictures the same way as your friend would look at the picture. And when the machine looks at your picture, the machine is able to learn how you look like and to learn how your friends look like. So very important for us, and it's a good lesson of computer vision, is we would never share the data or the knowledge of recognizing people among third parties. This data belongs to you. We always apply the same rule of privacy as Facebook, in the sense that if you put your pictures public, then they're public for everybody. If you make your picture private to only your friends, then as long as I'm your friend, I can use computer vision for my mobile device. So that's the way we solve the privacy issue. I have some selected ideas, selected features on technology. It's a vast subject. These are just some ideas so that you can look at. This is a regular pipeline of computer vision. So this is a very standard thing, and everybody in computer vision would understand what these boxes are. The difficulty on mobile device is this box must be done in 150 milliseconds. So when you look at computer vision on small machines, it's not really how sophisticated the ability to recognize someone is important. It's more how fast can you go so it's useful. And the challenge we had at Viewdle for a long time was, well, it's nice to do 1 picture per second, but on a mobile phone it has to be real time, and 1 frame on a mobile phone is 40 milliseconds. This says that in about 4 frames, we are able to identify who is the person. 4 frames is so fast that the human brain cannot even distinguish the waiting period. Other type of difficulties we had with mobile device is the unpredictability of the lighting condition. And for computer vision, lighting is very important. Or normalization to light is one of the key factors. Our first attempt was not very successful. Our second attempt is, I think, quite extraordinary. The first graph is the difference between the blue lines, which means I identify a person correctly, and the red line, which means I don't know who that person is, or more, it's I always make a mistake in finding someone. And you want the blue line and the red line to be as far as they can, so that you can adjust the decision process, which is always in the middle. So you want a decision process that is always touching the blue line very high and not touching the red line very high. And the first graph here is what you get using normal cameras of mobile phone. The second graph on the right, sorry, on the left, is the normalization work we have done into eliminating noise from cameras so that the signal you get from the camera is good enough so that you can effectively have a decision process that is larger, meaning you can be more on the blue line and less on the red line in most of the case. So we did this by doing normalization. And I'm just showing this to you. So these are subjects some of you know about this, but these are the things we like to show always because we were quite proud of how we did this. The source is usually really, really bad. It's unpredictable. So you have a big light on the side of the face, you are missing a lot of, or you have a big shadow on the right side of the face. The normalization techniques were able to eliminate some of the shadow so that you can work on something relatively normalized, which is the last line. These are the kind of challenges that you encounter in computer vision. You have this in many, many different cases, but remember, for a mobile device, you have to do this in 20 milliseconds. You have half a frame to do this job. That's why it's difficult. The other subject I wanted to show you about technology is where we are going, or let's say not where we're going, but where we spend some time as research. You're probably not going to be surprised. Many resources we have are working on 3D reconstruction. 3D reconstruction is the ability to take one picture of someone and recreate a three-dimension model of that person using one picture. These techniques exist for a number of years. What was difficult here was to do a model that is accurate. meaning to be able to reproduce a 3D model that effectively look like that person, in the sense that you can then inject this model into a mobile phone for the mobile phone to generate better understanding of who that person is. I put here a timeline, and you can see how these things evolve and change. When we started this, it took actually 15 minutes. Then in 2009, we went to 10 minutes. Then in April last year, we were in 5 minutes. Then right now, we are in a few seconds. This is the excitement we have when, remember in the beginning, I was talking to you about the dream we have of using computer vision to solve real consumer use case in real time on a mobile device. Is the first time you try, it's impossible. The second time you try, it looks a little bit better. After 4 attempts, you're going to say, yes, I think we can do it. And this is where we are. Thank you very much for your attention.
Okay, go down to the which? Okay, yeah, got it. There was the vision computing piece of it. So thank you, Laurent. That was great. We're gonna introduce the way this format's gonna work is we're gonna introduce. Hold on one second, Dr. Lee. We're gonna introduce the panelists, and then after I introduce the panelists, you can come on up or pre-introduced. Hold on one second, but sit down. And then we're going to have some comments specifically on Viewdle, and then we're going to talk a little bit about the industry in general is the format. So our first panelist is Dr. Faye Faye Lee. She's assistant professor and director of the other V Lab, the Vision Lab at Stanford University. Or maybe we're the other V Lab. The interesting thing about Dr. Lee is I went and I Googled this topic, and I came upon one of her lectures, which was in a very nicely laid out format in the class description. And I went and I said, this is good. And I went and looked at the class description and said, well, you need, for this class, you need algebra and statistics. And I said, well, I've taken algebra. I got that covered. And then I went and looked at the statistics. I took a statistics class in business school. And then I actually opened the presentation, and I said, boy, am I really glad I never signed up for this class. Because it was like hieroglyphics in terms of the stuff you had to know to understand the topic. So she's teaching some really hard stuff. Our next presenter, she's going to give a quick background. We're going to come back down and hear from everybody, but let's get everybody on stage first. Egosa Omugui, founder and partner at Echo Ventures, probably best known for his work at Intel Capital, a mainstay of Silicon Valley, someone who's been part of the capital formation process for many great startups, which I won't list off, but a friend and someone we're excited to have on the panel. Our next panelist, Munjal Shah, founder of Like.com. Munjal was actually spoke at an event that Vader and the Funded put on, I don't know, what, a year ago or so? Yeah, it was a great presentation before he was acquired by Google, or his company was acquired by Google. And what I was impressed by in that presentation was not just that he was a great entrepreneur and a visionary in a really pioneering category, but a very disciplined manager of his business. I think a lot of the presentation was about the way you managed by metrics and the way you had constant improvement programs. And I think a big piece of this, is my guess, is continuous improvement and actually making optimization a daily activity if you're in this business, because there's a lot of work that has to be done. So it was a great talk, and thank you for giving that talk, and we're looking forward to hearing you this evening. Last speaker, Dr. Eitan Sharon. Come on up. The CTO and co-founder of VideoSurf. You're a new face to me, but we're glad to have you here. A new entrepreneur. We have Munjal, a rock star, successful entrepreneur, and we have a new up-and-coming rock star entrepreneur. Ask him how to sell it for $100 million. And also of note, a graduate and had his postdoctoral at the Mathematical Sciences Research Institute at Cal. So go Bears. Okay. So with that, I was given this note this note is your question card. So if you want to ask questions of the panel, after we have our first half of discussion of Budel and our second half panelists talking about the industry, we're going to have our third half, which is questions from the audience. So please fill out your card, make it something that I can read so I can make sure it's well represented. So with that, I wanted to turn over to our panel and have each panelist give a, I guess we'll start down at the far left with Munjal and get a quick background of who you are if you want to, but really focus on your thoughts generally on the industry and any opening remarks you might have.
Nice to meet you all tonight. We started actually Like.com as a different company. So we started originally as a company called RIA, which did face recognition for organizing your personal photos. So this was before iPhoto and Picasa came out with that technology. And one of the insights we had at RIA was this idea of contextual recognition. We believe that fundamentally a lot of face recognition is very brittle, and so if you look this way or this way or this way, it just wouldn't work unless you can figure out some other technique. 3D, even that I'm a little skeptical about. But we realized that a lot of personal photos came in sets, and so chances are that there's only one person wearing, a certain green shirt in that set of the birthday party. And if I can get one picture of the guy looking straight, and I find the green shirt again, but he's doing this, so I can't quite tell who it is, I could probably say it's him. And so we call that contextual recognition. We looked at other things than just the face. And we launched that, built that out, and actually ended up in the end pivoting the business, realizing that it's hard to make money in face recognition and hard to build a real business. And ended up building Like.com, which used similar technology around visual search. So we searched inside the photograph at the color, shape, and pattern, and used that to help you find other similar products. And we did that specifically focused at soft goods. So clothing, shoes, handbags, jewelry. You don't need to do visual search on digital cameras. The look is not typically how you search a digital camera, but it is how you'd search a purse or a certain carpet pattern, etc. And we built that out and eventually sold it. So one of my core things, though, is for everybody kind of in the computer vision land, is one of the key things we learned in looking at face recognition versus similarity is this concept of kind of glass half empty, glass half full. So if a user looks at 20 results and you get 18 right in labeling who it is and you get 2 wrong, humans are so good at this, they look at it and they go, oh, how could you get those 2 wrong? My aunt doesn't look anything like my mother. So it's very glass half empty in terms of user expectations. On the other side, we found that similarity was a very glass half full problem, meaning if you clicked on a purse and we showed you 5 other purses that looked similar and 15 purses that didn't look similar, you didn't focus on those 15. You were like, wow, I didn't know these 5 other purses existed that looked like this one. And so one of my core lessons in applying computer vision is find the glass half full problems.
That's good.
Very good.
Okay. Benchmark on Munjal's length of introductory remarks, which was perfect. Egosa, what are your thoughts on this category? And as an investment, what are your thoughts on first off, who you are, and then as you're moving into being an investor in this space potentially?
Sure. So again, echoing Munjal, thanks for having me. My name is Egosa, and I am an investor. I've been doing this, I think, for a whole bunch of years. I still remember meeting Munjal in 2005 and trying to get into RIA then. I have been interested in sort of the much broader semantic technology space for about 11 years now, and sort of self-taught the science and the art of a variety of semantic technologies. Always loved computer vision. It was always very clear, though, that it was going to be one of those classic Hollywood stories. It was going to take 30 years to become an overnight success. And part of the reason was a lot of this science worked really well in very constrained data sets. When you open it up to sort of the larger consumer opportunity, it really broke. And I think to echo Munjal as well, when you looked at some of the things in facial recognition, it was very clear to me the only way you could monetize it was in police lineups. Outside of that, there was just really not very many opportunities to really do this. But that said, I was always very bullish about it. I think it was very clear, even back in 05, 06, that it had very clear dependencies around first of all, the power of the processing unit for the devices. Having worked at Intel, it was obvious to us then that looking for very client-specific use cases that consumed a lot of the MIPS, made things like computer vision a very important area for Intel to study. And so I worked with the folks in the labs to really look for a variety of opportunities, one of which was Viewdle, and we really liked the vision. I'm sort of known as an investor that doesn't flinch, but I flinched for that one, and part of it I think was that it wasn't clear to me that even when we went in and and we were able to deliver a sort of consumer delight, that we could monetize that. I think that has changed dramatically, and one of the reasons why I was excited to come to this panel tonight was I think there are going to be some extremely fun use cases starting this year and going forward. Now we have very powerful devices in our hands. They're much more powerful than some of the things we had in our server farms, 10 years ago, 5 years ago, which is just astonishing. And I think with that and the combination of computer vision with machine learning, and most importantly augmented reality, I am particularly excited that we will now finally see some of this science getting into the hands of consumers. Again, we have to be very, very careful about how we build business models around these, because I don't think that's a trivial task, but nonetheless, I think I'm very excited.
Great, thank you. And Dr. Sharon, you have both an entrepreneurial and an academic background, so we're looking forward to hearing your thoughts.
Thank you. I'm very happy to be here, and a lot of the preparation work that was done by previous speakers, Laura and Munjal and Negosha, about the challenges in using computer vision. I'm coming from VideoSurf, and VideoSurf is a computer vision-based search engine for videos. Our task is to simply connect the users with the videos that they care to see and watch over the internet, coming from tens of thousands of sources, to find it and locate it and present it to the users on a search page. What's unique about us is that we have realized a couple of years ago, 3-4 years ago, that a search for videos is unique in the sense that you really want to see what's in the video, not only what's around the video. Imagine a world in which you cannot see what's in a document, just search for documents based on the title. That's a situation now with videos that we have changed. We are actually looking into the videos. We are processing each and every frame, and to echo on Laurent's presentation, we are doing this 10 times faster than playback time. So we are able to process frame by frame hundreds of thousands of videos a day using 22 regular standard servers. We do that in order to see what's inside, who's inside, what's the screen time, what's going on, and find the precious moment and the people in it for you, and improve the relevancy and the UI of the search for the user to get better search results. And we measure these to be a multifold better from the third-party partners that we send traffic to. We also are happy to have announced recently in CES just a couple of weeks ago that we have a partnership with Verizon to put a special application which is all about vision on their new 4G mobile devices. And this application is to simply put as a Shazam for videos. You point your mobile phone at the video, at the live TV or at any video for a few seconds. We hit the right video for you, even if it's live TV. We have indexed it in the background a second ago, and we show you who's inside, what's going on. We allow you to share and recommend to your friends. We think TV, against to echo on things that were said, there is the most social experience ever, and letting you interact and cue that and watch that and share with your friends would be our goal. This will be preloaded on the 4G machines. As a video search engine, we have reached over 22 million uniques a month, and we are serving lots of traffic. So we're very excited to have the computer vision power the search, be it textual, visual search, as I just remarked about a mobile approach, and even we call it a recommendation search by you just being present, and we know what your activity is, and we feature you what you like to see best. We have a very powerful set of scientists that are experienced in the industry. Professor Achi Brandt is our chief scientist, founder of the multi-grid field. Dr. Ran Borenstein is running our computer vision team. And we are happy to combine the computer vision with the business in this efficient and attractive way.
Great, thank you. And Dr. Lee, opening remarks.
So yeah, my name is Faye Faye Lee. I feel very privileged to be here and feel very privileged to actually be directing the only academic computer vision lab in the heart of Silicon Valley. And I moved my lab from Princeton 2 years ago here. So I guess I'm the nerd representative here. And being the nerd representative, I feel that I don't have the pressure to say anything that might lead to money or profits. So computer vision is a huge field. It's my passion, my students' passion. And in this short 1 to 2 minute, I guess just coming from the academia end, I want to highlight 3 major topics or application areas that I see computer vision serving technology, serving society. So the first one actually, Laurent already touched upon, is reconstructing and augmenting reality. So a picture is more than 1,000 words. It can give you immersive immersive perception, a lot of experience that's beyond the pixels. And you already give an excellent example of Vudo product. Also, there is a recent technology from Microsoft called photosynth, where you take your own photo with thousands of photos of other people in a landmark. Suddenly you get a 3D reconstruction of, let's say, the Eiffel Tower. So that kind of technology is just extremely exciting. Again, I don't know how that makes money, but I think augmenting and reconstructing reality is one way computer vision would revolutionize or serve the society. The second area I find extremely exciting is what I call improving safety and quality of life. And traditionally, especially in assistive technology, we have seen, say, driving assistive technology. There's a startup called Mobileye and many others. Stanford is where we had the winner of the DARPA Urban Challenge, DARPA Challenge of unmanned vehicle driving. We also see our society is moving more and more into a lot of senior citizens, and that's a major area that computer vision can serve the society. There's also a lot of health topics, for example, recognizing food, recognizing the calories, and environmental issues that I think computer vision can move into to serve the society in a very fundamental way. And the third topic is also very dear to my own heart. There's a lot of research going on in my own lab, is what I call the managing the gigantic information explosion. And thanks to...
Just a little thing.
Yeah, and you'll be surprised how many academic computer vision papers published in the year of 2010 that has somewhere in the title the following phrase: size matters. So YouTube sees 24 hours of videos uploaded every minute. Facebook is getting millions and billions of pictures uploaded every month. And thanks to Moore's law that hasn't broken, your hard drive is increasing or doubling in size every year and a half. All this is creating a gigantic information explosion. And media data is something that we have not yet managed to control and search and index and tag and do many things. And this is where a lot of skepticism of the industry and the investors are still worried about, because is our technology mature enough and so on. I don't have time to talk about the details. This year, starting 2011, so I've been a professor and I've been teaching core computer vision class at Princeton and Stanford. Starting 2011 is the first year I start to tell my computer vision classroom students, I see computer vision at the cusp of revolutionizing information age. Google has done that in the text and document world starting 10 years ago. And with a lot of computer vision research and machine learning research coming up, I see this as something genuinely coming to change our lives.
Great, thank you. So I want to honor Viudal and Laurent's presentation, but what I don't want to do is have it be like a pitch event kind of thing where we're just going to beat him up, and that's too easy. And he didn't. He also didn't give us a whole lot of detail on the apps specifically, so it's tough for us to really pick them apart like we could in a private session. But but I think what I would like to do is talk about the general topic and talk about the category he's in and where we're going to see. From a business standpoint, and then get more into academic and where we're going to see the future going, kind of in the second half. But I think maybe down at Munjal, you're clearly in a place where there's all kinds of stuff related to search and discovery and new applications. I'm sure abounding, even just like as you're waiting for lunch or something. So, what would be your thoughts after looking at Viudal and the direction he's going, and feedback for Laurent?
I think he had a little detail there, so that's okay. It's just harder to kind of comment specifically on his. I mean, I have some general thoughts on the kind of space and things.
Sure, that'd be great.
We can kind of go to that. But I think that if we look at the space, there's some interesting ideas that are areas where I would explore if I was looking at this. And these are my own opinions, by the way. These opinions are not those of Google, blah, blah, blah. So, my disclaimer. But one thing is, as we think about computer vision, I might ask everybody to define it more broadly. So I think of, Data from Star Trek with his little visor where he sees in other wavelengths, if you will. I think there's some really interesting applications if you move away from the visual wavelength. So there's some fascinating ways that you could actually look at things in other wavelengths and be able to detect cracks in pipelines and cracks in ship hulls and lots of industrial applications, but also some interesting other applications as well. So I would kind of encourage everybody to say, let's not define this as computer vision just in the visible visual wavelengths. Let's apply this in kind of the entire electromagnetic spectrum and think about like what else you can see in infrared, in other things to kind of look for interesting applications. So that's kind of one very concrete element. The second is coming back to glass half full. I actually read this the other day where somebody had set up there's like a blind intersection, and somebody had set up a camera here, and then as the car was driving up, they postulated, what if, as you're now projecting lots of information onto the windshield, your speed and whatever, what if you could actually have the view from around the blind corner projected onto your windshield before you made the turn? And I'm like, oh, that's a pretty simple but quite useful, life-saving application. And not a hard thing to do, actually. Maybe not even a lot of computer vision, although it would be nice to be able to like just align it in the screen with what you're actually seeing so that in a photosynth sort of way, it just kind of all merged together, but you basically could see behind the wall. And so I thought, that's a great glass half full problem, meaning, the intersections where I don't have it, I don't have it. The intersections where I do get that, I get it. I'm like, wow, this is neat, and more will come up over time. And it's not terribly complex computer vision, but it truly kind of helps the scenario. So I think that's another kind of interesting one. I'm less excited about augmented reality, to be honest. I think there's just some challenges with how to access that world. Like, am I going to pull this out every 2 minutes? I think there's just some elements of that that are difficult, in terms of that. But.
Cool. Igosa, yeah. I think you brought up a great point, Munjal, that about where are the actual applications going to be in the near term? Is it going to be sort of what we'll call enterprise applications and things which are used by businesses? Is that going to be the easiest low-hanging fruit, or do you think it's going to be in consumer? And as you look out on this category, are there any big rocks you're looking for things that would be important to you from a near-term investment standpoint?
So I think this is 4 years ago. So the original, I wrote a sort of a core thesis around what I thought would be opportunities that you could embrace and extend into CV. And I called it sort of extensible sense and presence. And so what you're really thinking about is, one, if you let me just sort of back up here. You think of your classic social network, and you're thinking that everybody you're connected with, your first order connections in your graph. One of the challenges that I certainly have found, is that too much weight is put to the knowledge that is contained within that first order connection. And there's a whole lot more information sometimes that you need and want that is beyond that first order connection, the second and third. And so what you figure out is how can you then dynamically create what I call social fractals. You're able to now create these clusters of people and interests and knowledge. And then you then project yourself into the center of that. When I looked at that, sort of overlaying that with extensible sense and presence, what I found, talking to some amazing entrepreneurs like Laurent and co, was everybody was sort of really looking around the present, right? Whereas there were interesting things you could do, almost Star Trek-like, by teleporting, or what Cisco now calls telepresence, right? And and I think there's some very interesting applications in that. I think Munjal did a fantastic job of sort of giving you some ideas around industrial applications, but even within sort of the enterprise, telepresence is somewhat trivial. It's been done, it can get better, but it's somewhat trivial. I was much more interested in very specific things, like, for instance, the ability to take use case. Munjal is in Paris. He is shopping. He has his camera. I'm sitting in Silicon Valley. Munjal says, hey, there's some interesting things here. I connect to him. And then he's sort of walking around, and I can sort of follow what he's doing. I can send additional information to him. Augmented, I know he doesn't think that augmented reality is there, but I actually think there's some interesting use cases there. And I can bring a lot of these dynamic digital information layers into his presence. I'm essentially teleporting digital information, my presence, on his. It sounds like it's Star Trek-like, it sounds ridiculous, but interesting enough, I've actually seen that application. Some folks in Europe are actually working on that. It's fascinating, right? And so I think what we see is, no pun intended, what we see here is how many ways can we monetize these types of interactions? You can easily go, someone can claim telepresence is $300,000 per install. That's great. But for the individual consumer, right, and because I still think the enterprise is maybe a little bit further out, but for the individual consumer, I think one of the things that you get is, are they willing to pay for instant information, right, or instant add-ons, right? And I think we've seen this in gaming, right? The ability the willingness to pay for what is drivel, the virtual, hoe, or the virtual knife, or the virtual whatever it is,
or the golden eagle in Angry Birds.
I denied publicly any knowledge of that game. But I think what you find there is that you can actually create some of these layers, and more importantly, sort of from my perspective, I think you find that once you're able to create clusters of interest, go back to the social fractal networks, you're able to create clusters of interest, you're able to narrow down specific layers of information, you're going to be much better off monetizing those types of use cases, right? There might be smaller social networks than you're used to. They won't be the 650 million Facebook type stuff, but they'll be much more targeted, right? And I think that's actually this year versus anything else. I think we're going to see this year.
Cool. Wow, that's a heck of a prediction. All right, Dr. Sharon, you're probably the most close to Laurent in terms of a current entrepreneur working on new tech. What are your thoughts, both in the presentation and just where you see the opportunities on the street, the this year stuff?
Yeah, so first of all, the mobile aspect of things. I actually think that it's not mandatory that we will see the processing being done on the machine itself. It could very well be like in the mobile application that we have presented in this demo, the Shazam for videos, that we're actually sending the information off very, very fast to our server farm, and you see the processing going on in the background, even for live TV or whatever you may be doing on the other end, and feeding back the information to the user. So I actually think we'll be seeing, hopefully this year, definitely from us, the sending of the information to a server farm and sending back a complex computation that is, to echo a bit on Faye Faye's words, we do it fast enough, but still it needs a server farm, and you could still leverage that with current mobile devices. Regarding the social aspect of things, as I mentioned before, I think watching TV or videos is a very social activity, which involves being engaged with what you see, and this opportunity there of identifying could extend to other use cases where you actually know a lot about what you're seeing on the back end. So you know about the products, you know about the people, you know about what's going on, and you can generate and leverage all this information to the users as they're identifying what they are watching. This is to echo on the usage of computer vision versus mobile. I would add to that I think that connecting the technology to the bursting field of videos that we see, billions of searches a month, billions of views a day, is essential in order to control the explosion of information that was mentioned here, to put some order in it, to make it searchable, viewable, to organize and sort it out so that you can find what you actually want in the order that you want. And we're seeing in interacting with many partners that they are interested in us structuring and organizing through our APIs the content for them, and we use vision to do that. I didn't even mention, but fingerprinting technology that we have allows us to see each and every overlap between each and every piece of visual content, and that allows a lot of carrying on the knowledge of stuff that reappears over across the internet in order to structure the data. So that's another aspect to go and do. And of course, the common engagement in facial detection, facial analysis in real-time speed would be, I think, would come to play in some apps that may come from Viewdale or from other players in the field.
And thank you. And Dr. Lee, from a sort of a broader macro perspective on advances in the science, what are your thoughts on both with Laurent and the industry in general?
Wow. Well, actually, I was just sitting here and feeling scared. I'm thinking that all these successful startups, and if Agosa is right, then I'm not going to have good students who want to be graduate students anymore. They're all going to go to startups.
It's called advisory board and stock options, Dr. Lee. You got to really leverage yourself out.
Yeah, we have to talk.
We can talk later. I'll say I set that up.
Yeah, so, well, okay, so let's talk about Viewdale first. So I have to say, I don't know if anybody knows this, that at least the legend goes that computer vision started as a field as a summer project to 1 or 2 undergraduate students in MIT who had nothing better to do but wanted to work in the lab for 2 months. And at that time, it was artificial intelligence lab professor thought, well, you know, we've got some math, we've got artificial intelligence, some equations. Vision is just an application, and these 2 smart MIT kids will solve it in 1 summer. And here we are, 45 years later, and there's still an explosion and growth of this field. And it's amazing that face recognition has gone this far. You know, it's a singular topic that computer vision has worked on for so long. The field collectively has spent, I would say, at least 20 years in this. And to just see that Viewdale has taken this far, you know, we go from 10 minutes a year ago to few seconds. You did write along Moore's law here by faster chips and memories.
Because we didn't do it well the first time.
Oh, I see. Yeah, MATLAB was. So
We can talk.
She knows all your secrets.
Oh, yeah.
So someone who don't have much interest in money, at least not yet, I just feel very, very proud of my field and very happy to see that computer vision is, you know, getting this far. But I guess you also want me to.
We can hold on if you want. I want Laurent to say one more thing before we open up. So we're gonna get some broad questions from the audience too. Okay. So I got under strict time rules here. We're gonna soon move on to the audience questions, but I want to give you a chance to give a couple more comments.
So about my presentation.
Yeah,
I liked my presentation.
Defend yourself.
So I liked it. You asked me, right? Yeah. So the difficulty is exactly what you said. Actually, is a glass half full or half empty, and what is interesting in our case is that when you combine a social graph with computer vision, you can actually reduce the problem enough so that if it's about finding your friends and family on a device, it's okay, because as long as they are in front of you, the device will say that's them. Right. And if they are not in front of you, the device will tell you, hey, I think this is one of these three guys. Can you help me with a touch screen? Who these are? So the use case has always been a nightmare, and making sure that the glass was full or half full was always the most difficult one. And I think the reason why it works now is because of the combination of two things. One is the devices are very powerful, so you can do actually more things than you could before. The second thing is the device is on you. So if the device says something wrong, you can correct it with a touch screen. And the third thing is that the device is connected. So it's connected to your social graph, so we know who your 20 friends are. And we also know that there are a lot of pictures of them on Facebook or other places that we can use to teach the engine, even without you knowing, as long as you authorize that. Even if you don't know it, in fact, the machine learns in your back. So the use case here is you're trying to identify your friends and family. You know who they are because they're most likely on Facebook. And the device is powerful enough so that when you restrict the use case to these, it kind of works. That's the idea.
Great. I like the Facebook app. Find me a girlfriend looks just like mine but likes football. Do I have any more questions? Okay.
We can talk.
So the first question, you're going to write that.
We actually built that app.
You built that app? That's fantastic.
I'll tell you what happened.
Yeah, that's fantastic. It's going to be huge at college campuses. All right.
So you see, that's Ezra, I just want to point out, that's the classic route to a really good monetizable opportunity.
It is.
Because one, it's a subscription
TM.
business. Yeah. Two, if you find that face, and there's a similar face, you can sit down and say, okay, X looks like a celebrity.
Right.
And then once you find that person, you can then transpose pictures or graphics of outfits that celebrity wears on that new person.
Right.
And then you can make those images clickable.
Right.
And then people can buy the images, click on images and buy the images. Now that's a CV business model.
That's right. And you can say like the CTR on the Dallas Cowboys is off the charts, and
exactly.
Next thing you know, you're getting high CPMs. Okay.
Right.
So all right. So on that note, actually, I think the first question up, I'll give it the honor of reading it. It's a good question for the panel. Where's the money? Any new business model potentials? Digital science for consumer ad world? Where do we feel? I think this comes back to the what's this year question. But on quick thoughts on where the money might be. Dr. Sharon, what are your thoughts? Where's the money?
So definitely in the approach that we're taking by searching for videos, there's no need to represent the need and the consumption of videos over the internet these days, both, as I mentioned, in number of searches and in numbers of views. The opportunity there is pretty simple. We are able to monetize, and we intend to monetize the search, just like Google does for text. And these would be promoted relevant results. We will connect the users with the content they want to find, and we'll help them, and we'll help the providers, the owners, and the aggregator of the content to promote some of the content. And we'll use the same model. So that's one definite way to use the business around videos and computer vision combined in order to see the money.
Okay, great. And we're going to move quickly through these questions. There's some great questions. There's a ton of them. So I want to get one person's feedback unless someone's really dying.
Well, I have one example of where's the money that is, that you know, again, is an augmented reality. So I'm not sure how many of you're familiar with augmented reality. So I led, the last investment I made at Intel was a company called Layer, and they do this augmented reality browser. And so you walk up, you put it up, you know, and it essentially tells you not just where you are, but it starts to tell you what's around you. So I have another investment in a company called Retailgens that does real-time product inventory for offline stores. And so you can imagine now what happens when you put a camera up against a store and it tells you what's in the store. Yeah. You can click on it, you can purchase it. You don't even have to go into the store.
That's awesome.
That's a real business model.
Right.
Right? So I know AR. I know you don't think AR is there.
So this, I'm going to direct this question.
We coming.
We coming.
This is AR night.
We coming.
I'm going to direct this question at Munjal and Dr. Lee, because I think this is a good one for you two to answer. One representing the cloud, one representing the classroom. What constraints are holding back the industry? Computing power or algorithms, academic comprehension, business models? So Dr. Lee, what is holding this industry back in your mind? Or the field?
Yeah, so let me answer what is holding the solution of computer vision problems back. Let me give you a piece of fact that you can infer from that. So there's a reason my lab is called Vision Lab, not Computer Vision Lab, because I also do human vision, neuroscience. And it is known in our brain cortex, 50% of the neurons or more are devoted for visual processing. That's by far the largest sensory system and computing resources our brain has devoted. Vision, pixel world or visual world is simply very, very complex. So there's many reasons, factors that's holding us back, but I think fundamentally algorithms and mathematical solutions are lying in the core of it. The evolution has spent billions of years to solve this, or we're racing against, I don't know, like 6 months for each series of funding.
It's actually
hope
12.
that AR comes in 6.
It's 12.
All right, so what's holding back?
I'd say the same answer. You know, if computer vision, let's take face recognition, if it was completely accurate, I can think of 100 apps that would all make a ton of money. But it's not. And so, I mean, we all would love the app that, you know, we just look at somebody and we're like, who is that? And it instantly tells us what their name is. Like, you know, who doesn't have that need? And so, but it doesn't work that well, you know. So I think that's, accuracy is, at least in the recognition realm, the biggest challenge, which then leads us to the second challenge because of that accuracy, which is basically finding apps for which the accuracy today is sufficient, or constraining the problem using social networks or other ways to kind of make it not be a, you know, kind of a completely horizontal kind of solve everything at once. So I think we just haven't figured out how to, you know, create an accurate system. And by the way, you know, humans are good at this and have a lot of processing power, but if you think about this notion, how many times do you see somebody, you're like, I've seen that person before, but you still can't name them?
That's a memory problem.
Yeah. You got augmented memory too? Yeah. I'm waiting for that
I'm
one.
on the phone with Micron right now.
So speaking of, but I think, I mean, you're right. You can do a better job. You know, Hal, who is that? Well, Munjal, that's... You guys went out in college. Okay, how do you see the emergence of consumer-level 3D vision hardware? Kinect has sold 8 million units, 3 months, affecting the vision industry. So 8 million units, Kinect, it's really cool. I saw it at a demo. Who wants to answer that? Everybody seems to have had relatively equal time. So anybody jumping out on terms of how this is going to affect 3D hardware and other kinds of new products in the short term? You got a thought?
Yeah, it generates a lot of competition.
Yes.
Yeah. No, what they are doing is very interesting. They are using different cameras, and they are using correlation between the different cameras to do some 3D reconstruction. It's not really reconstruction, but to estimate the depth of the images. So what I hear from my friends at Microsoft is that certainly computer vision is the #1 topic at Microsoft, and a lot of people are excited. They have a big lab in China. You probably know this one. And this lab in China, I remember I was at Microsoft 3 years ago, and they keep telling me, "Oh, we have everything." And then I keep asking them, "So where is it? Where is it?" And 3 years after, it's still not there. Right. But what happened is they found Kinect, so they didn't do it. It's another company who did it for them. But suddenly, the Chinese lab is very important for Microsoft now.
Cool.
Can I just add one thing? So I'm completely guessing, and I'm not responsible for all this. If I were to bet money, one thing I would bet on, based on all these connected technologies, stereo camera.
Yeah.
Hey, what's that?
Stereo camera is the camera that, just like humans, we have two eyes because we need to solve the 3D reconstruction problem. We have to navigate, we have to know depth. That's why most animals have multiple eyes. So I think the future, looking at this, I would bet that stereo camera would become more and more important.
I agree. I think you will see the first sets of those cameras this year. Yeah.
Is that going to take like Harry Potter pictures that move around and stuff? Or
well, you know, they're essentially just giving you sort of a three-dimensional approach to photos.
We can do very good reconstruction that way.
So I mean, I think that's there. Now the Kinect. This is very. Yeah. I know someone who cannot stand the whole concept of the Kinect. It's my 3.5-year-old daughter.
Really?
Because he doesn't see her. No matter how my son moves the thing, it just doesn't see her because she's too small, too short. She has to stand on something, and it's not working for her. When she's 5, it will, but it doesn't work for her today. And so you think about that kind of opportunity, and you realize that we're still not there yet. Right. We still have to make compromises here and there, but. I've played one, and I have one, and I think it's an amazing device. I'm not sure if you guys are familiar with Perceptive Pixels. It's a New York-based company. If you've ever sort of seen the is it Mission Impossible thing where he's moving elements of the images, right. That's here. Yeah. You can see a trivial representation of it on CNN, right? But that's here, right? And so you start to think of very interesting elements and applications for that when you can actually engage with these images and objects. Right. That's it's astonishing.
So maybe
Perceptive Pixels.
Maybe one quick remark connecting the previous question and that last question. If you are able to process fast enough, and this was our emphasis, and to talk about the algorithms that Faye Faye mentioned, then you can analyze videos. If you analyze videos, you actually see things from multiple views. You see the distance, you see the depth. There's an abundance of information there. So our emphasis was always on the speed of the processing, and we think if you are fast and efficient enough, you get to have this information, be it in a video or at a robot wandering around. The movement provides you with those multiple views that would help a lot the recognition as opposed to one particular photo. And the challenge then is speed. So tackling speed and scalability is a huge issue that promotes recognition and results.
Got it. Several questions in here. Back to Dr. Lee's big three, but safety and quality of life. Several questions about military and safety and so on. But I guess my general thought would be, compressing these a little bit, is are we going to see significant advances in the next sort of 5 years in terms of safety? Are we still going to have to wait in TSA lines? Can we just get zapped by something that can look through everything and we just walk through? Are we going to see things change? Munjal, you're leaning forward.
So two things there. One is there's a company we worked with a long time ago that was struggling kind of from one grant to the other, but basically a company called Blindsight, which was working on basically building a camera that you could point at anything, take the picture, do text detection, do text recognition, and then do text to voice and read it. Why do you need that? Well, there's a lot of people in the country who are legally blind, which means they can kind of make out that there's text there in the shadow, but they can't actually read it, especially if it's a sign that's kind of high up, they can't get to it. And fascinating application. I think that there's a lot of assistive areas where it's just perfect use of computer vision. You can actually do it quite accurately, and you can do it quite well. The other area is, I think as you approach computer vision, one way to combine it in a way that'll actually work is to not take a pure algorithmic solution. So one of the things we found is what I call a bionic solution. So I call it kind of do 98% of it, with the computer, but do the last 2% of it with some human beings, because there's always this part that you're just never going to get the computer to properly be able to handle, but yet it's very important to creating a successful application. So some of that is actually, if you look at some telepresence technologies, you can say, you know what, I can train this thing to move around here and put these things away, but every now and then it's going to get stuck. And it won't know how to back out, and it'll just get confused on where to drive next or what to do. And those might be perfect times to kind of send that camera up to an operator who every time it gets stuck can kind of unstuck it. And suddenly you have something that, basically would have been useless without the human, the bionic, I call it bionic, kind of half computer, half man, but without the bionic solution, you would have ended up with something like, oh, I can't deploy this, it's not a real thing, it doesn't work yet. With the bionic, you're suddenly like, this works, it saved thousands of hours. It requires one person now instead of 100 people, but it still saved me 99 people. And
the
so
power auto nanny, put her toy away type 2000 thingy. That'd be awesome.
There's some interesting applications for that. I mean, you can actually, I saw this guy who built this device around window washing for high-rise buildings. And it'd be very hard to actually build a window washer that wouldn't get confused by certain corners and things. But if you had an operator sitting in, I don't know, India, who then, would move you around that corner, and then it could continue where the surface is now uniform, and then you could move you around the next corner, you actually might have a working solution.
Yeah, that's great. Yeah.
So
Plug it into Mechanical Turk or something.
Can I add to this?
Yeah.
So last year, involuntarily, I spent a lot of time hopping around U.S. military bases and Pentagon. I was forced on this panel from Defense Department. So two comments. One is, can we speed up the TSA line? After spending, a good 30 days of my life hanging out with the military and Defense Department, my conclusion is that most of these are political questions, political solutions. There's nothing computer vision can do. But But there are things computer vision can do. So I don't know how many of you know this. Starting in the early half of 2010, it was a historical moment in US military that more unmanned airplanes were flying in war zones and serving the war than manned airplanes. Just that piece of fact alone is calling out for amazing amount of vision technology. And it's a niche market. It doesn't serve the 600 million Facebook users.
Unless you want to kill them.
But it's more than, I heard, I might be wrong, more than 13% of the US government budget is spent in the Defense Department. Yeah. So there's another market.
That's great. And so we're going to bring this full circle. We're almost out of time on the clock here. We got a few minutes. We're going to close with the question that was handed to me. Back to Vudel, but again, this is a general question. We'll go down the line, start with Munjal and work our way back to Laurent, who can have the last word here as our guest of honor. Can we address the business challenges that Vudel faces? Additional funding, customers, revenue. Each of you in your own area of expertise. Provide some feedback, and he will have a chance to say a couple thoughts. But Munjal, what if you were Laurent and Vudel right now? What would be the things that would be getting you up in the morning and keeping you up at night?
I think it's hard to assess his business challenges without knowing the exact applications. Right. So I think it's kind of just can't answer the question. But I
had to ask it, so
it's fine. It's just. Kind of the presentation didn't have that information in which to assess. But what I just say is I think that is actually the main element, which is can you find an application for which the technology is sufficient, sufficiently good, and there's some path to monetization, eventually. I think in Silicon Valley you don't need a direct path. If you can get significant traction in usage, you can kind of defer that. But I kind of always feel like you don't have to be in the revenue stream, but you got to be near some big river somewhere that people see. So.
Yeah, big river of money.
So I've never, I think over the years, I've sort of, I said this in my opening remarks, that I've not seen better monetization of facial recognition than the police lineup. I've just not. I haven't, and I'm not sure I ever will. I think though that what could potentially be interesting as a business model is to, and I hate this phrase so badly, is to gamify the process. One example is to do a facial recognition and then, create some sort of polling or voting about the kinds of clothes and things that you can put on the person. And those are real items that people can go purchase. You can purchase outfits. You can, almost similar to the virtual showrooms that you find in sites like Select Together and maybe Polyvore. But I think, other than just pure facial recognition within the consumer, I've seen this, Keystream did some very, very interesting stuff with facial recognition, but it's almost impossible outside of security and intelligence to effectively monetize it. You can do some stuff with celebrity pics and the like, and I know you have a little bit of expertise in that, but, there's only so far you can go with that before it doesn't really sort of scale to become a relatively venture-backed, interesting opportunity. It's not big enough. But I think if you gamified what you were doing and allowed people to vote, and they did not necessarily have to be first-order connections, they could be second- or third-order connections, that could get interesting in a hurry, because then you're selling not just virtual goods, but you're selling real goods.
Got it. So my take is we're in the Bay Area, and users vote with their feet. And I think that the first point in making something that is monetizable or makes money is to have users use that. This is why I'm so proud of our 22 million uniques and the usage and the video searches. And I think for Laura, the challenge would be to get large usage. And the challenge would be further in terms of the technology to somehow dance or balance between being able to recognize the people that you already know that are near you to the people that are too far, that are not interesting for you. I can share, for instance, that with us, we have found that around 60,000 models of people cover over 95% of the video content that people actually consume. So that's a way to dance around it. You do not have to recognize each and every person on the planet, but a few tens of them cover a lot of the video content that people care about. If you do that fast enough, if you do that scalable enough, you can actually go back to the explosion of information and help people. And helping people, I think, in sorting out information and structuring it, that's a huge help. People are after information in videos and in text, and they need the help to get it through whatever is surfacing around the internet. And this is at least the Videosoft take on these things.
Great.
Okay, so instead of giving Laurent advice, I'm pleading to you and Dr. Sharon and Google that
I already agree.
please hire computer vision PhD students. And I'm not joking, this is a very difficult area, and the 50% neuron tells you that it's a huge algorithm problem that we haven't yet to solve. And I'm convinced there's money. Agosa will tell us where, but I'm convinced there is, so hire the good PhD students.
We do. We have plenty of people that graduated. We don't take them before they graduate. We take them after they graduate.
Thank you. We can fund their labs.
We sometimes do that, though.
All right, Laurent. Good admission. Good admission. Full disclosure.
So,
but not tonight. Not tonight.
No, we have 8 PhDs in our team. We have incredible guys. There's a guy, he won the Olympiads in mathematics when he was 14 years old, and then at 15, at 16, and at 17 he won 2 Olympiads, mathematics and...
Must be Russian.
Yeah. So, in terms of talent, we are very lucky. We tend to hire people all over the world. We don't really care where they are. We tend to, I mean, it's exciting enough and it's interesting enough, so you really find young PhD students or PhDs that are interested. In terms of business model, this is, it is very hard, as Agosa said. excitement we have, I think, on the business model is the fact that you can apply visual computing to a social context. And when you do this, you reduce the use case in a way that it becomes possible, but you don't reduce the excitement because the social context means that it's your friends. So I can't speak too much of the apps. We have not yet make announcements on this. I bet that you will see our technology in several devices by the end of the year, if everything goes well. The excitement is that it works in these cases. And when it works, it's a kind of a magic moment where you say, you point the camera to your friend and say, wow, it found you. Also, the business model we are excited with, and I'm surprised we actually didn't talk about it too much, is in games. Is the fact that you use computer vision to bring some reality inside the game. The reality means that the machine understands better the reality than the GPS would do. And by doing this, you make the game very exciting because it's unpredictable. It depends on the reality. And you can share the reality with your friends as well. So these are the things we work with some of the partners. Number one is injecting some of these techniques into devices for general purpose application. And the second one is injecting reality into gaming aspects. I can't really say what these games are or what these applications are, but you should see that soon.
Great. That's right. Everybody here's the beta. Got a beta program?
We will make.
I can't tell
we
you.
will make an announcement soon. Yeah.
So,
I can't tell you.
Ezra, I just want to add one more suggestion for Laurent. So we're sort of now at this intersection of search, the flip side of search, which is discovery, which is a much harder sort of content sourcing mechanism, hyperlocal, and I guess the next generation of it, which is nanolocal, social, and then of course you have sort of this underlay, which is gaming. Now, one thing I've learned sort of over the years in doing investing is that, and I guess my dad always told me as a math major, he was like, somebody has solved your problem somewhere. That person just doesn't know it's your problem, right? It's the way it works. And so you step back and you think, okay, what can I do by analog or by metaphor? And, so I take you to Amazon. As trivial as the people who liked X bought Y, as trivial as that thing at the bottom goes, it generates north of 60% of the purchase clicks. So you step back and you go, okay, so what can I do in my model by way of metaphor? Right? And if you take the facial recognition that you're offering, you now sit down and say, okay, I create some contextual adjacencies, I throw some metaphors in there, I get engagement, and then I get monetization. Yeah. So it's one thing to think about as you sort of, social graph, nanolocal, gaming, find some intersection there. I think that there could be some interesting exploration opportunities there. I can't say you're going to, it will succeed, but, at least you'll die trying.
Munjal, what's the final word, and then we're going to wrap it up. So Munjal, what's your last comment?
So one actually piece of advice for you, and this is, we had to make a transition as we went along the way in our journey from a company that we thought about ourselves as a computer vision company to really not a computer vision company. And so there was a key moment when we launched Like that we realized the users wanted additional features. They wanted to be able to filter by sale price. And we're like, well, what does that have to do with visual search? And that was kind of the fundamental moment we said, wait a minute, we're not about visual search. We're about helping you shop better for soft goods, clothing, shoes, handbags, jewelry. And if you can actually see the tagline of Like kept transitioning. It was like visual search, and it was like visual shopping. And then eventually when we just launched the new product with Google called boutiques.com, the word visual search isn't anywhere. The positioning isn't anywhere. The feature's still there. It's still promised, still a key part. But it's it wasn't about visual search. And so I think that that was kind of the key thing I tell you is figure out what you want your thing to be and make it about that. There may be a computer vision part that's a component of that, but there may be other parts that are, you know, kind of my net is computer vision may be necessary but not sufficient to make a great application. Figure out your application, make it great. Use computer vision as appropriate, but don't define yourself as a computer vision company because that's a platform or a technology that's not an application.
Great closing words. I apologize to all the folks who we couldn't answer your questions. I'm on the verge of not being invited back for another 10 years if I don't wrap this up. So I want to thank Laurent and our panelists. Great feedback, as you can tell. This is like bursting off the stage. So with that, I'll hand it over to